Okay, for this video, I will talk about the heat exchanger and I will just use one of the example to explain all of the things for these questions. Okay, so let me teach you how you want to do for the heat exchanger part. Actually, you need to list out of all of the things that they given, okay, so that you can do the questions. Okay, in here we know that they have say counter flow heat exchanger. They already say counter flow heat. So you need to highlight it or do anything you want because this is the quite important informations. Then with two shell passes, four tube passes. Okay, so this also one of the important information. You also need to highlight it. Then it's used to cool oil from 125 to 50. Actually, we have cold 125 to 50 degrees Celsius. This is also one of the important information. We also have the flow rate at 2.5 kg per s. This is mass flow rate, which means your m dot equals to 2.5 kg per s. Okay, then your medium is oil, 125 to 50. So we know that your oil actually it is the heat input. Why? Because they get cooling down. The cooling water enter the shell at 20 degrees Celsius with a flow rate of 3 kg per second. Okay, you need to highlight also the cooling water enter the shell of 20 degrees Celsius with a flow rate. Okay, for these questions, actually they are straightforward. They already tell you the cooling input is water because they already say the cooling water and the oil is the heat input. Okay, if they didn't mention it, which one is the cold or which one is the heat, actually you can take a look on the temperature. If the temperature of the initial temperature of both, one is quite higher and one is quite lower, the quite higher actually that will become the heat input because your purpose to doing the heat exchange actually to cool down the heat things and heat it up the cooler thing. Okay, so we list out all of the things. The water is 20 20 until how much we do know. Okay, then we have the mass flow rate of 3 kg per second and the overall heat transfer coefficient for the heat exchanger has been estimated 121 watt per meter square Kelvin. Okay, so we know that our U is 121 W per m square times K. Calculate the heat transfer area required. Actually, they want you to find your A lah. Given the specific heat of water and oil is 4.18 and 3.55 kJ per kg Kelvin. Okay, the specific heat, these things we call it CP lah. So the CP for water is 4.18 and the oil is 3.55. Okay, this is what we get. Okay, now after we take a look on the questions, anything, actually the correction factor is appendix for you. Actually, they were given in appendix, so you need to take a look in your appendix. So now we know that it is counter flow heat exchanger, so we need to draw it out. Okay, draw it out. You need to draw counter flow. Okay, when you talk about counter flow, actually there are two things, something like this. You need to draw this. This is counter flow. Okay, if it is current flow, how we want to draw? Actually, the current flow is like this. Current flow is like this. Okay, how you want to memorize it or remember it, it depends on yourself. If me, right? Okay, this is counter current, and this is current flow, which means they will enter the same place. Then one thing, they will increase their temperature. One thing, they will decrease their temperature. From this, we know they are decreasing their temperature. This will increasing their temperature. So we already know these things. It will be uh cold. This will be cold input actually. No H lah, I just write C in for cold input. Why I say it is cold input? Because temperature is increasing. The temperature is increasing to here. Okay, so we already know this is C in, so actually this will be C out lah. Okay, this will be hot in. Hot in, that temperature is going through down, so this is hot out. Okay, so for this, for here, okay, we need to draw which one is heat in and which one is heat out. Okay, if you want to know which one is heat in, which one is heat out, from this you can see that one of the line is going down and one of the line is going up actually. So we know that the temperature going up actually is cooling. Cooling, the temperature will going up because they absorb heat from the heat medium, or we say the heat input. So this will be your C in, this will be your C out. Then this will be H in, this will be H out. Okay, now how I want to know, either our C out is higher than H in or H in is higher than C out. Okay, this you need to memorize. How you want to memorize? We go to our note. When you go to your note, actually you will take a look. Go to our note part 2. They already tell you. Ding ding, this one. Okay, we already know C from here, H in. This is H in and this is H out. C in and C out. So you need to memorize these things. Actually, these things they are also the same one. Actually, you draw like this also can, or you draw like something like me also can, because there are no any changes actually. But if you not confident for your drawing, you better follow the graph or the profiles they're given. You just memorize it or do any things you want. Okay, if you really don't not memorize it, or you feel confused with other graph, so for easy understanding, I think I will just using the graph, the profile they given. Okay, so wait a minute, I will draw it out for you. We take a look at this slide first. You need to memorize this graph actually. For these things, do this, you need to memorize because it will give it in your final exam. Okay, so we talk about counter flow, right? Okay, so I draw something like this. Okay, out, T co in. Okay, this I will say as T2, this I will say T1. Okay, now I already draw it out, so we back to our slide. Okay, for this slide, I already draw it out. The TH in, TC out, TH out, and TC in. Okay, so please don't draw like this actually. You can draw it like this, more proper. Because I just want to explanation, so I would draw like this only lah. Actually, there should be something like this. Not like this, but this is should be not like this. This is for easy understanding. So I just write it off for this. Write it off. Okay. When I write it off, okay. They already lag. Oh, okay, never mind. Okay, when you draw these things, okay, you already know which one is your T1 and which one is your T2. Now we back to the formula. We take a look on the formula. What should we do? So in the formula, uh, we know that okay, we know that this they have the T log medium temperature or TLM lah. Okay, log mean temperature, and then this talk about the TLM. Okay, now maybe some of you need to ask, in what situation I need to use TLM and what situations do I need to use TM? Okay, and what conditions I need to use this log mean temperature difference and others. Okay, so in here, before I talk about that, let's talk about TLM. Okay, actually the TLM we will use quite common in the heat exchanger because it had a more accurate result if you're using it. Okay, never mind. For the questions, they say 2 shell passes, 4 tube passes. So they already say lah, 2 shell passes and 4 tube passes, which means they have multiple pass. Okay, so when they have the multiple pass, we need to do this, the mean temperature drop, because they did say in case where a multi-pass heat exchanger, one shell 2 tubes, one shell 4 tubes, 2 shell 4 tubes of shell and tube heat exchanger is involved, you need to find this TM, the mean temperature drop. Okay, so how about we do it one by one? Okay, to it one by one, we take a look on this formula first. TLM equals to this thing. Okay, so I write it in our slide first. Okay, now back to our exercise. Okay, I already write it. These things, I already write it. So we need to find our T log medium first. So we write TLM equals to change of the second. Change of the second is here. Okay, then I need to label out what we have. We need to label out 125,550. So the hot in is 125, hot out is 50. C in is 20. Then the C out is X. We unknown. We don't know what is it. We don't know what is it. Then how come we want to know it, and what formula should we use to calculate it? So let's get back to our slide. Okay, when we get back to our slide, I need to find these things. These things. Do you feel familiar? These things. Okay. So they say Q equals to MO. Q equals O. Q equals to the mass flow rate times the specific heat of the hot times with the hot in minus hot out is equals to Q. Q also can be equals to mass flow rates of the specific heat of cold times with the cold out minus cold in. Do you know what it means? Which means is your energy balance on the hot fluid can equals to the energy balance on the cold fluid. Okay, so then we can find out the cold out. Okay, so let me write out the formula for you. Cp hot, Th in minus Th out, Q equals to mCp cold, Tco minus Tc in. Okay, so now we back to our slide. Okay, in my slide I did write it, these things. So at the end, actually, it can be the same things. Okay, like Q equals to this thing. So we substitute these whole things into here. At the end, it will become a general formula of H1 minus TH out equals to the mass flow rate of the CP coal, the specific heat of coal, times with the the C out minus the C in. This is your formula. Mm, I think they are lagging. Okay, yeah, here you are. You already find it. So after I find it, I need to put all of my information in it. So in your questions, we know that the mass flow rate of the hot is 2.5 kg per second. Kg per second times with the Cp of hot, which means the oil is 3.55 kg per kg times K. Then we have the hot in is 125 minus the hot out equals to 3.0 K per S, 4.18 kg per kg times Kelvin. And then we also have something called cold in is 20 and cold out we still know. So X minus cold in. Okay. In here, maybe you will ask something. oh, what happened to here? They have the Kelvin and I'm using the Celsius. Do I need to change anything? Actually, you don't need to change anything. Why I'm talking something about like this? Okay, because in here you are finding this is talk about the temperature difference. Temperature difference. Okay, temperature difference. Okay, if you learn about PCP, we know that when we're doing the conversion unit, actually one of the Celsius, actually it can be one of the Kelvin when we calculate it. Okay, and do you know why? Why the Kelvin we can change it to one Celsius? Do you know why? Actually, they have some of the conditions when you to convert these things. Is convert this thing when the Kelvin is per Kelvin. Here, you see here over Kelvin. You see this. They need to in the unit. If today your things is 3.55 K, actually you can't directly to become that degree Celsius. But if today your Kelvin is under the fraction, actually it can become under the Celsius. Do you know why? Okay, actually in the PCP they talk about this only. But in my explanations, okay, I will talk it more details why it will become like this. Because now for this specific kit, you are finding you know that 3.55 kJ, 3.55 of energy per kJ times with your temperature, right? Do you know what the meaning of the temperature that per that? Actually, it is talking about temperature difference. I use an example and you will know it. If today I want to find temperature difference 125 minus 50, take out your calculator and calculate how much is it. 125 minus 50, actually you will get 75 degrees Celsius. Okay, if today I change it, both of them become Kelvin. 125 plus 273, 398 minus 50 plus 273, 323. Then it will become 398 minus 323. It also will be 75 degrees, but it is in the unit of K. So this is why in PCP, we know that 1 degree of Celsius, actually it can convert to 1 degree of 1 Kelvin. This is the reason, because if you're finding the temperature difference, they don't care about either it is Celsius, either it is Kelvin. Okay, so if we talk about the Fahrenheit or the other somethings like, we don't need to care about it, because in engineering we are just talking about the Celsius and Kelvin. About the Fahrenheit, about the pound mass heat, we don't need to care about it. Okay, we just care about the Kelvin and Celsius enough. Okay. So you no need to worry if you're finding something that in the appendix they are per Celsius or per K. You no need to worry actually, because at the end your your temperature difference will also be the same. So there are no any effect even though you change your Celsius to become Kelvin and then times with your specific heat or heat transfer coefficient. There are no any effect on it. Even though you already covered with it, but never mind. That would affect the result actually. So I just clean it off this and we start doing our calculation. Ho, 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 ho. Okay, so we do our calculations. We need to find x. So using your calculator, just find out your x lah. So I will show it up. So we just simply times with it. 75 times 3.55 times 2.5 uh, over 30 over 4.8, 4.18, then plus 20. Actually, your code out will be 25.3. Yeah, it will become 25.3. Oh, is it 25.3? Okay, If you don't confident with your answer, you can calculate one more time actually. No need to worry. 75 over 3.0 over 4.18 plus with 20. 73. 73.08. Okay. How you want to know your answer is either correct or not when you're doing the calculations? Actually, you can know it by common sense or logical thinking. If today the heat, we know that the heat in and heat out, the temperature difference is 75 degrees Celsius. And we know that if, I know that if the difference of heat is 75%, and we need to do assumption for this question actually, when we're doing the heat exchange. Later I will talk about the assumption. Okay. In the assumption, we have one thing. We call it no heat energy loss, which means in the whole thing's heat exchanger, they are well insulated. So I will I will talk it later. Okay. So 73.05 degrees Celsius minus 20, 50 above 50 degrees actually is quite make common sense. Okay, so we already know our answer is correct. When I already get this, now I need to find TLM. Actually, I already can find our TLM. So when we do TLM, we just put it all inside our formula. T2, actually T2 is uh, TH out minus TC in. Okay. Actually you don't need to know lah. Which mean the difference of the difference actually you can't know it at negative. You need to make it become positive. So the biggest minus the smallest. Okay, no problem. So we know that T2 is T out minus H out minus C in. So our H out is 50 minus C in is 20. So minus the change of T1. TH in is 125. And then C out is 73.08 degrees Celsius over, please don't forget your unit. Okay, you can draw like this only, also okay. If you forget about the unit, you can just draw it like this. They will accept, no need to worry. So the change of the 2, actually 50 minus 20, it will become 30 over 125. 125 minus blah, 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 blah. Okay, actually we'll get 51.92. Okay, now we go to here. You just use your calculator and calculate it. Minus 125 minus 10, 10, 10, 10, 10, 10, 10, 10, 10, 10. Actually, you can find 39.96 degrees Celsius. Okay, is it make any common sense? If 39.93 actually is my common sense, because they already told you the log mean temperature, which means the temperature is between the change, the T2 over T1 actually. If the TLM, the range is between T2 and T1, then your answer should be correct. We know that, right? It is between T2 and T1, the answer, because T2 is 50 and then T1 is 30. So actually, they are in the range, and quite ironic. It is considered as 40, so it is, yeah, it is the middle of between the T2 and T1. So yeah, this is the answer. You can confirm your answer by using this kind of logic. Uh, but if you lack out of time, just do it one more time, or you feel tired when if you thinking about logical. So okay, after I get TLM for these questions, okay, every time for these questions, if they give an appendix something like this, actually they have their use. Okay, They have their use. Don't think they have no use if they're giving any appendix. They won't give the appendix that you won't use. So after I get TLM, now I want to find my TM. Why? Because it is multiple pass exchanger. So actually I want to find my TM. So let's go to our slide. When we go to our slide, okay, this I will talk it later. Actually, this equation we will use it, no need to worry. Now I go to these things. These things is just only theory. Just to just read it by yourself. Okay. This also almost the theory. This we will use it later. Never mind. This thing, this thing, this thing. Okay. Now I want to find TM. Actually, I want to find TM. Okay. Well, how we want to find our TM? Okay. So I just draw it. I just write it out our formula first. Okay. TM. Okay. I will go to others first. Because I want to find two tubes, four shell. Two tubes passes four shell. Okay. These things you need to know. You will use it later actually. This. So for this graph, I already know I need to find effectiveness. I need to find effectiveness. Yes, I need to find effectiveness. But before we find effectiveness, we don't do anything first lah. Okay, we just calculate one by one. We don't go too fast on it. Okay, so I will go to this. This they already give you in the slide, right? Okay, so we no need to take a look on it. We just go to the slide. I just open the other slide for later. Where is it? Where is it? Where is it? Where is it? Okay. Okay, so I already found these things. Oh shit, sorry. Actually, this is TLM. This is TLM. Okay, don't make it wrong. Now I want to find my FT. Okay, double check is it our formula correct or not? Double check our formula. No, our formula is this. Okay, remember it's this. Please don't make any mistake on this formula. Okay, now our formula is this. So I will enlarge it. Okay, now from this we need to do any assumption first. Do you have TLM? Oh yes, you already get your TLM. Okay, do you get your FT? No, unfortunately I didn't get my FT. We don't have any FT. Okay, we don't have any FT, but we want to find TM. Okay, so in these cases we only can find FT, which means our correction factor. How we want to find it? Okay, they already give you the graph. Okay, they already give you the graph. This they already give you this graph. You need to use this graph actually. Uh, Actually they already give you this graph lah. This is more for your easy understanding. But but the things is they say two shell passes, four tube passes. They already give you two four exchanges. But is it only we have the two four exchanges? No, we have other graph that beside of two four exchanges. So we go to this the slide. We know that for this log mean temperature difference, actually this is finding the TM. You find out they list out it is one tube one shell two tubes and one shell four tubes exchanges. So this graph we can't use in our questions because they talk two shell four tubes. So this one is for two shell four tubes. So this is the graph that we will use. Other than this, actually you have a lot of graph. You have graph like this. The the parallel flow for the this you need to calculate yourself. Actually, for this you need to calculate yourself. But maybe you will say, what is the function of using all of this graph? Okay, I will explain later, no need to worry. Okay, the following, this one you need to just take it a look on yourself by yourself. Okay, so I want to know my ft. So for the given formula, they already given your formula actually. Okay, for the z actually is this line or this line, the curved line. For y actually is your x-axis. For y is x-axis, and you need to find your ft by y-axis. Okay, so now let's go. We do our questions. How about I just do it beside. I list out all of the things. H in is 125. H out is 50 degrees. Cold in is 20. Cold out we calculate is 73.08 degrees Celsius. Okay, when you list out all of these things, now it is time we do the calculations. Let's do one by one. I do y first actually. Why I need to do y first? If when you're going into the final exam, you already blur, you don't know how I want to find my z, or actually you blur already, you don't know how to do, right? Actually, I have a tips for you. You can find out your x-axis first. Why? Because when you find out your x-axis and you are lucky enough, actually you have the more higher chances to find your correct ft. But I hope that don't have the cases that you forget how to do or you're too panic to do the questions. I hope that won't happen in the final exam. Just try your best. So we do the y first. Y equals to cold out is 73.08 minus the cold in 20 over hot in is 125 and cold in is 20. So my y is using your calculator is 0.5055. Okay, better you use 3 to 4 decimal places and then uh, to become 2 decimal places because you need to round off. Okay, so it is approximately 0.51. Okay, so after I get y, I need to get z. Before I get z, how about I draw a line on the y first? 0.51, almost approximately here lah. Okay, so after I do these questions, uh, actually I don't, yeah, I do these questions. Okay, now from this part we already know lah. Uh, if your y is 0.51, actually it will intersect with which line? Actually, you already know. They only have three possibility to what we say, to intersect with the curve line, but we still need to do the z. Okay, so the z is hot in is 125 minus hot out 50 over c out 73.08 minus your c in 20. So take out your calculator, calculate it. No need to worry, this calculation is quite easy for us. Okay, it is 1.41296. Actually it's 1.413 lah, or actually it's 1.41. Okay, we just take two decimal enough lah. Okay, 1.41. Okay, from this we already know lah where is 1.41. No need to busy about it. Okay, how I want to know is 1.41. Okay, uh, just take out your baris, take out your ruler, and then measure yourself. Okay, actually I won't say measure one by one lah, because actually usually commonly I just using my eyes. Okay, but never mind, I will use a ruler and point it out for you. Okay, 1.5 to 1.0. uh the difference, 1 2.4. Okay, from here to here is 2.4. Then I need to separate out with 5 part actually. So 2.4 over 5. For every 0.48 centimeter, I need to draw a line, 0.48. So no need to worry. Just take out your ruler, list one by one. Uh, how about I just use 0.5? Actually, they're almost the same one. So we have one line. We have two line, three line, four line. Okay, 1.1, 1.2, 1.3, 1.4, 1.5. Okay, settle. This is what we can get. I think. Hello. Ho. I did drop the line. My Wi-Fi. Please wait for a minute. My Wi-Fi on my iPad already lost. I think it's boring to take a look on this slide. How about we just take a look on our slide. This make you more interested in your heat transfer. Okay, I will talk about effectiveness later. Okay, no need to worry. Actually, you have to do all of the exercise. Okay, because I just only can help you one of these. I just only can help one of the question only. I can help all of the questions because I think in the quiz 5 you can know all of the method already, so no need to worry. Okay, let me get back. Wait a minute. Do I share the screen? Okay, let's share our screen. Start broadcast. Okay, do I share my screen? Yeah, I'm sharing my screen. Hold on, hold on. Okay, so we know that. Okay, back to our question. Why it will become like this? And actually, okay, so what's going on? I think I'm sharing my slide, right? Hello. Okay, so we know that this is 1.1, 1.3, 1.1, 1.2, 1.3, 1.4. So 1.4 almost at here. So you draw a line, 1.4. Okay, so we take a look, they almost have the intersect on here lah. Please use a ruler, don't draw like this. Okay. Wow. Approximately 0.88 for our FT. If you have other answer, you can tell me. Okay, I get 0.88 with my raw eyes. Okay, so I get 0.88 for my FT. So now let's get back to this formula. 0.88 times with your change of your TLM, 39.96 degrees Celsius equals your TM. So your change of TM actually it will become, use your calculator. Oh, I get 35.16 degrees Celsius. Okay, if you get this, Congratulations, you can go on for another part. Okay, now I already get the change of my TM, your mean temperature. Now we are going to calculate the heat transfer area required. Okay, until here, I need to check which things I already use. Do I use the counter flow heat exchanger? Yes, we already draw the graph. Tick, make a tick. Two shell passes and four tube passes. Do we already use the appendix? Yes, the graph. Give a tick. We already know which one is hot in, hot out, cold in, cold out. Yes, we already know. Please take a tick. Flow rate, we know. Yes, we already use it. Take a tick. Okay, all of this we already know. Take a tick. Do we already use the overall heat transfer coefficient? Oh, unfortunately, we haven't used it, so you can't take it. Then calculate the heat transfer area required. Oh, we still haven't do it. Okay. Given the specific heat of water and oil, do we use it already? Yes, we already use it. So give it a tick. Everything. Okay, now we go back to our questions. You need to find out Q equals to, and is it M? No, it's not M. U times A times TM. This is what you should use. This thing what you should use. Okay. But now I have a question I need to ask. We have TM, yes. We need to find area. I have U, yes. Do I have Q? I have a question. Do I have Q? Okay, you can. I will give you 3 seconds and try to make the answer in your heart or in your brain. Do you have the Q? In the count of 3, 2, 1. Okay, actually the Q already given for you. Okay, why? We go back to the slide and take a look. Okay, now you know these things. This thing. Q equals to UIAI, then the mean temperature. So in other words, this Q, what is this Q? Actually, these Qs are same as these things. Okay, when we talk about same as this thing, actually it is same as wait the slide is quite long. Actually it's same as this thing also, but this we use to calculate the Q max, which mean the heat transfer maximum. Okay, actually you are using this. You are same as the energy balance or hot fluid and cold fluid thing. So you have this formula actually. Okay, now maybe you have a questions. Do I need to use the energy balance on hot fluid or energy balance on cold fluids? In these cases, we already calculate lah the Q actually. We already calculate the Q. They already have the energy flows for the cold fluid and heat fluid. So just use. Which one do you like? Just use it. Okay. So in this case, I will use hot fluid because hot fluid they give you the totally uh you can't say totally actually the most complete information. Okay, so I calculate 2.5 times 3.55 times 75. I get 665.625. I get 6 oh I get 665.625. Okay, if you don't know, actually you don't know what is the unit for Q. Okay, your Q, when you talk about Q, it is about heat transfer. Heat transfer is what? One kind of energy. So when you talk about energy, we'll use what unit? Yes, kilojoule or joule. Okay, so we use joule lah. Okay, now we go back to our questions. Oh, when I use the specific heat, when I use the M, I have the mass flow rate, I have the per second. Do I in my whole equation, do I have any time? No, you don't have any time. So you need to per s. Got it? Okay. When I have this thing, I need to calculate all of the things I need to use. Okay, now we go back to the upper. Is it our formula correct? Okay. Now we do simple unit cancellation. Okay, kg we cancel with kg, temperature cancel with temperature, so we remain kj per s. So already right lah, our unit equals to given 121 w over m square times with your k. Is it correct? We take a look at the upper 121 w per m square times k. So we go back to here. Now I want to teach you these things. Actually, this is very common, very common unit in heat transfer, in electrical technology, or even in your thermodynamics. They are very common. Is what? What is energy equals to joule per second. So in other words, kW equals to kj per second. You need to memorize until take it until you drop in the coffin. Okay, this thing you need to memorize it. uh there are no any unit conversion for these common things. So in here I already know this is W should be J per S, but here I use KJ per S. So depends on yourself, you want to change it which one. For me, I will, for simple calculation, I will change to watt to become kilowatt. Okay, so 123 it will become 0.121 665.625 kj per second. This is become kilowatt per m square times k times with your change of tm 35.16. Then we have area. Okay, so I want to find area. Area I will remain constant. All this thing go to here. So your area will become, calculator take out 665.625 over 0.121 over 35.16. Then you will get your area of 156.457. In other words, 156.46 meter square. So you get your answer about finding your area in this video. We finish to calculate the quiz 5. Okay. After we calculate all this quiz, now I want to talk about the fundamental things and all the important things when you calculate on, when you want to know the parts of heat heat exchanger. So I will talk it one by slide. So this we already talked about just now, right? So no need to get worried. No need to get worried. Okay. Now I want to know. I will teach you when I will use TLM. This oh I will teach you on in what cases we will use TLM and in what cases we will use about TM. Okay, please listen carefully. For these things, in for the TLM, we will use when it has more than one passes, which means more than one tube. Okay, if they say about single pass, which means they have one shell for one tube only, then you use TLM. If they give you one shell, two tubes, one shell, four tubes, two shell, two tubes, two shell, four tubes, you need to use TM because they already tell you in case where multiple pass heat exchanger, you need to use TM. Okay, we already know just now these things. You need to find it to take a look on your FT graph. This is the FT graph. Okay, so now I will talk about NTU method. Okay, for this NTU method, actually you are just finding your effectiveness only, no need to worry. Okay, usually the process, the step to doing this, actually they are almost the same as what I'm doing just now, but the only difference is when you calculate TLM, you no need to calculate TM. You no need to calculate TM. Why? Because they are given you other things. You see these things, okay? These things. Okay. effectiveness is this formula. Actual heat transfer, actual heat transfer is um actually you will find it yourself, and Qmax they will give you. Okay, but actually if they give you Q, if you find Q and they give you Qmax, actually you what we say, your calculation is very easy, but I don't think they will give the question easy like this. Actually you need to find Qmax and they will give you the Q, and you need to find effectiveness and you need to find your Qmax. Okay, now go to this formula. Okay, the actual heat transfer, these things, right? You talk, oh, what is these things? Is it the same things? Is it the more complicated formula? No, actually these things are same as these things. They are the same things. Why? Because the mass flow rate times with your C specific heat, actually it will become Cc or Ch. Ch is times with your specific heat of your hot fluid. Cc is your mass flow rate times with your specific heat of cold fluid. But how? How you know the Cc is that and Ch is that? Because they already give you. You see, the mass flow rate times your specific heat of the hot fluid, it will become Ch. Okay. This one you no need to remember this. I'm not recommended to memorize this, because the only things you need to memorize is this formula enough. Because for this formula, you can use in many different cases. And this is the general equation that you will use. These two things are actually they will be the general equation that you will use. So the Qmax, they already know. Okay, how I know the C minimum? How I know the C minimum? Okay, when you go to calculate these things, HC and CH and CC, right? Okay, you take a look on which one have the more higher number. Which one have the more higher number? They will become C max. Which one they have the lower number? They will become CC. Okay, now we go to this, the Q max equals to C minimum. This lah, the same equation that we'll use. So okay, effectiveness. This is the effectiveness. Actually, this effectiveness, right? That would came out this difficult for you lah. Actually, these things, right? These things, you can get from this. No need to worry. You just use your graph and take a look. Okay, for the graph, you need to find your. Actually, you need to find effectiveness from the graph. Then what should I get? What should I found to read the graph? You need to find this C minimum. Oh, these things. You find it C minimum over C maximum. This I told you just now. When you use your mass flow rate times your specific heat, the lowest number will be C minimum. The higher number will be C maximum. So for these things, you will use the lower number over your maximum number. It is not equals to it is not equals to zero. No need to worry. This is tell you that when it is zero, the line will be here. 0.25 will be here. 50751. Okay, if you find out maybe there are 0.25, 0.2, how about 0.21? Okay, they don't have the line of 0.21, right? So you use a ruler, make a make a line here. You just calculate lah, one by one, until where is 0.2. Then you draw a line. Okay, when you draw a line, you need to know the NTU. How you want to calculate the NTU? They already given you formula. This is the formula lah. This will be given. U is the heat transfer coefficient. The N is the area, and C minimum, as I say just now, mass flow rate time with your specific heat. The lower number will be your C minimum. Then after you get all of these things, you draw a straight line, then take on the curved line and find the effectiveness. After you find the effectiveness and you find your Q maximum using this, bravo, you can find your actual heat transfer, your Q. When you find your Q, actually the question will tell you to find the other things. Okay, from this, I already forget one things. For this graph, different flow, they have the different graph. If in the question that just talk about parallel flow or counter flow, take a look on these two graphs only. If they they say it is parallel flow, but they have the conditions of one shell passes 246 or two shell passes 4812, at that time you need to forget it is parallel flow or counter flow. No need to take a look on these two graphs. But I say you just forget about the parallel flow and counter flow, right? Counter flow, right? But you still need to do this. You still need to draw this to find your TLM actually. So after you doing your TLM, you can forget either it's parallel flow or counter flow. No need to worry, because I hope you are not confused when you doing when the question given parallel flow with one shell, two tubes. Because if they say parallel flow with one shell, two tubes, you are not looking on this graph. You are looking on this graph because one shell pass two tubes. You need to take a look on this graph. Okay. After that, you have these things. I already talked it just now. Exercise, folding factor. This you can read it by yourself. Okay. Now finish. Okay. So now after finish, I will talk about the heat exchanger. About no, I will talk about the assumption. So I will go to WhatsApp. Uh, I will go to the WhatsApp. I just sent it just now. Okay, this think where okay. I already have the link. Okay. This link you just find it yourself. I can't post the link on the YouTube, or otherwise I will get a copyright warning, because without mentions or without noting him. Okay. But this thing we don't need to take a look. Okay. If you are feeling you are very free after the heat transfer examination, you're feeling free. You can take a look the types of folding, the assumption, LMTD, these things. They will give you a more details explanation. Okay. But since we need to going on our final exam, so uh, I won't talk as detailed as them. I will just talk it touch and go lah. We just talking surface only. These things you feel very familiar, right? These things actually it is TLM, the change of TLM times with your A, your heat transfer coefficient. It will become, yes, your heat transfer. This NTU we already talked it just now. But they have a lot of memes actually. Okay, they have the summary, they have the short videos. Hey, I forget. Here. Dun, 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 dun. This one is the importance of conclusion actually. Uh, when if you are feeling interested, you can memorize all of this, because for these things actually you can confirm your answer in your final exam actually. If you memorize all of this, you can confirm your answer. Either your answer is correct or wrong. So now we want to talk about what? We want to talk about assumption. Okay, here there are 6 assumptions. Uh, you either memorize it or uh, or I explain for you. Okay, if today I'm say the heat exchanger there are no steady flow, do you think what the meaning of not steady flow? Which mean in the flowing they have energy losses. Okay, in fluid mechanics we know that if it is laminar, we can find our friction factor, and the friction factor usually they will become very higher means their energy losses is quite low. Okay, so and when it is turbulent, which means their energy losses, their friction losses will be higher. So they have the same theory and they have the same theory with the heat transfer. Okay, now the mass flow rate of hot and cold fluid is constant. In the other word, there are no any loss. There are no any friction loss. Okay, the inlet and outlet temperature as well as the velocity is assumed to be constant. Why the velocity of the initial and the final is same? It's also the same reason. No friction loss, no energy loss. Okay, we assume the situation is very ideal. The changes in potential and kinetic energy are negligible. This is also the ideal conditions why we need to ignore the potential and kinetic energy. If you're not going to ignore, you will using the formula in Dr. Sam Part thermodynamics. There's a formula that talk about non-flowing fluid and flowing fluid, right? In the formula, you need to use kinetic energy, you need to use potential energy. How you want to use? Actually, you just sub out of the information in your heat transfer, sub inside the equation. Actually, you can get the answer of the potential energy and kinetic energy. For easy calculation, we ignore all of these things. Okay, so yeah, that's it. Specific heat of the fluid is assumed constant over a specific temperature range, which means they're already given and we no need to care about it. The outer surface of the heat exchanger is considered as perfectly insulated with no heat loss to the surrounding. This is the reason why when you doing your experimental on the heat exchanger, no matter the shell and tube or the plate heat exchanger, there are the difference when you calculate it with your theoretical result. Because in the real life, they are no insulated perfectly. Even though they're insulated, they say insulated perfectly, they still have the heat loss. So in the assumption, we are writing what? Writing the things that are not going to happen in our real life, like perfectly insulated, no heat loss, the velocity, outlet and inlet are the same constant, the mass flow rate are constants. These things are impossible actually, but we need to assume it when we're doing the calculation. So I think that's all. I think that's all. I already briefing much of the heat exchanger part, so um, no need to worry. This slide, I think, I won't send in my YouTube. I won't send it. You try to do it by yourself. All of these things, I will scroll it slowly, slowly, slowly. You need to find it by yourself. I just give you an answer to you know what to get a double check and for your easy understanding. So that's all. Bye bye.